Cloud. There we go.
Well, welcome to the July 27th, 2021 session of TeamSpeak, or sorry, Tangerine SDR.
Living in the past.
It's an old habit. Tangerine SDR and HamSci technical sessions. So my name is Dave, KV0S. And this week I've been reorganizing my station. It's out of view from you. You can probably see a bigger pile of junk behind me, but I now have my computer station fixed up quite a bit nicer. So haven't done a huge amount of programming, but I'm getting ready to be able to do some more things. Next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you, Dave. It's been a very busy week here in Scranton. Last week, we had the Radio Blaster Physics Camp, and we had Scotty come visit us from Arizona to Scranton. And so he can give you a full report on what it's like being here and staying in the hotel and where we want all of the HamSci workshop things to be. And we had 14 very excited high school students and about 6 college students working on it. I think it went very well. So it was a really good week. And then I also, as I was saying before the telecon started, we received notification that a NASA grant to study traveling atmospheric disturbances in the ham radio data has been funded. And that's going to involve Bill Engelke in the University of Alabama and Phil Erickson and the MIT Haystack Observatory. So we have been doing very, very, very well. And that was very exciting. So we have, yeah, we've been doing great with the funding record so far. So it's excellent. And just trying to keep everything going. So W2NAF, back to net.
Very good. Next on the list, we have Dev, KC3 PVE. Go ahead, Dev.
Hello, good evening, everyone. As Nathaniel said, we are starting our new week here in Scranton in good spirit. So we had good news of Nathaniel receiving a new grant. And I'm also continuing to work on finalizing the algorithm to analyze the variabilities in the HF chop sounder observation that we have been receiving here in Scranton. Thank you.
Very good. Next on the list is Scotty. W.
Wow, I must have got boosted to the top. Oh, that's
You
right.
boosted yourself up, so you get to go early. You want to go late?
No, it's okay. I'm just not used to being called much ahead of Tom. So anyway, so last week was physics radio blaster camp in Scranton, which is great. I got to visit Nathaniel, got to see Dev, got to have dinner with Jonathan. I got to meet the other grad students. It was great. Lots of fun, and seems like a lot of interest in the 14 students who were the high school students who showed up. Hopefully they can do that again next year and with maybe 100 students instead of 15, because it would be great to get that many. It was really interesting that if I remember right, and you correct me, Nathaniel, if I'm wrong, but I think when the instructor Deck asked them how many had heard of ham radio before, no one raised their hand, not one. And then when he asked how many are going to be interested in getting your ham radio license at the beginning of his lecture, 2 people raised their hands. And then after he continued on for about another hour about ham radio, and I think maybe it was after your talk, Nathaniel, they asked how many people want to learn Morse code, and 5 people raised their hands. So it's like they're getting the enthusiasm. They're going to want to get their ham license. I don't know any use for Morse code other than ham radio, since we're the only service that still uses it. So implying that there's going to be almost, at least a third of them who are going to get their ham licenses, we hope. And also, I attended the ARDC board meeting this past Saturday. And so Nathaniel, one of the bullet items on their to-do list of giving grants out is funding equipment for college amateur radio stations. So I think that you get that in, I think you're a shoe-in to get it, because you certainly have the enthusiasm, enough hams there, and they're looking to give money out. So go for it.
We're doing that.
Yeah, okay. I just wanted to let you know that it looks really good for the prospects. So, and the other thing is I just sent you an email with the request for funds to try and get us off the dime here, given the fact that we can't build any data engines. So, by the way, I went ahead and bought another one of those development kits because the number was down to only 5 left at DigiKey. So I think in probably by the end of tomorrow, they'll be sold out. Now, I don't know how many people, maybe that's because everyone here on the list went out and bought one after last week. So
I
run
bought
on
2.
and Nathaniel bought 2. Anyway, the idea is that we're going to take these off-the-shelf development kits, and I'm asking ARDC to fund the development of an adapter card that will adapt the RF module to this off-the-shelf kit, so that we can do FPGA development and we can check out the RF modules ahead of time, before we get any data engines, because it's looking like it's going to be next spring before we get any parts to build those. So at least the guy building the off-the-shelf boards can get parts, so we can get adapter. If we can build our adapter board, we can check out RF modules. And then as part of the proposal, I was asking for funds to build the clock module carrier board, which is the one that John Ackerman was working on. And he's actually got the schematic mostly done, but I'm asking for funds for layout and prototyping, and so we can get our professional layout guy to do the layout job, and it will accept the clock module. And since we have all the parts to build clock modules, we can go ahead and build RF modules and clock modules. And if we get this funding, we'll be able to test out both of them and get them all debugged and all ready to go by the time the data engine comes down next year. And in addition to that, I got the preliminary preliminary information on the Data Engine Mark II FPGA, the Arria 10 that we're planning to use, that will give us the capability to do 10 gig Ethernet on the board. And actually it'll give us the capability to do 10 gig and 40 gig Ethernet, both. We won't be able to do 100, but we can do 10 and 40. And it turns out if we were to build new RF modules that would have double A to Ds on them and use both input channels and put 2 cards in, we can generate about 20 gigabits of data. So 20 gigabits per second of data. So that we could actually overrun a 10 gig E channel, but we couldn't overrun a 40 gig E channel. So 20 and 40 seems to be a good combination if we can get if we can build it so that it will accept either SFP card. Because the main difference between 10 gig E and 40 gig E is the fact that 10 gig E has 1 channel at 10 gigahertz. The 40 gig E has 4 channels at 10 gigahertz. And the FPGA we're using has 12 transceivers, and we need 4 ins and 4 outs, so we only need 8. So this will be able to do that if we set it up right. And in the meanwhile, what I'm going to do is I'm going to divert a few of the funds from the assembly of the data engine to buying these parts, because I've got to place an order for them before I can get them delivered. And the delivery is estimated to be October of this year. So about 6 months ahead of time of the data engine FPGAs, we'll get the DE Mark IIs. And I think that's probably going to be pretty accurate, because by the time you factor in building the adapter boards and getting the Mark II board designed and laid out, it's going to be October anyway, probably. But and then we're going to need some additional funding from ARDC to actually build the Mark II, and that will be a subject of another grant request that I'm going to do for Tapper. So we'll see how that works out. They seem to be, ARDC seems to be very interested in issuing grants. They have lots of money. They have to get rid of it by the end of the year, and they're really looking for worthy causes. And I don't know what more worthy cause than ours, because it meets all of their requirements. It has to do with ham radio, has to do with education, has to do with state-of-the-art radio technology, just meets all the criteria. So anyway, we'll keep things rolling and try to keep the project moving forward. I don't want to stall for a whole year. So anyway, back to you, Dave.
Well, fine business, Scotty. Thanks for that report. Next on the list is Bill, AB4EJ. Go ahead, Bill.
Well, thanks, Dave. Good evening to you. Good evening to the net. Been fairly busy here. I went through and did the work to add the observations table and the associated tables to it, related to it, into our prototype central host. When you have a Django system, if you want to modify the database, you don't go in and modify the database directly, but rather what you do is you develop a model that is a software logical model of what the database structure should logically be, and then Django uses a migration process to actually add that into the database. So it's kind of a ticklish process. Kind of had to learn how to do that, and because I had not done that before, but we figured out how to do that. And so my student was on vacation who was working on this through the summer. He's back now, so we should be able to start playing with the observations table now. We've got to develop the user interface for that. So as planned, the way it will work is as a Tangerine, if it's in command mode, where it's commanded to upload based on a data request from a scientific super user, or if it's running in Firehose remote mode, the observations will go up and will automatically be stored, and the metadata will be put into a cross-reference database, which will then be searchable various ways. So we're moving in that direction. Also, I took some inspiration from what Dave showed us last week on the charting and developed a strip chart function that runs under the local host. I only have it showing one channel now, just shows the Y channel, because that's the one that seems to be most sensitive to the field and so on. But I can add, so where it shows all 4 channels, XYZ in total. Anyway, that is running in a prototype mode with a single channel now. So thanks very much for the inspiration on that. By the way, Dave, I'm using something called chart.js, which I found it a little bit easier to understand what was going on than the die charts that you are working with. But I mean, it's great that you got yours working too anyway. So also did some work, Nathaniel mentioned earlier that the NASA grant is coming through. I'm getting my ducks in line to get all the data put together and make sure we have it all stored and backed up. So I've got all the RBN data going back to the very beginning, the raw data, and I'm going to go through and make sure I have all the PSK data, the raw data. The raw data coming from PSK it's in the form of SQL insert statements. So I've got software which unloads that so that it can be stored as straight CSV files. The only problem with it is it doesn't have the call signs in there. It provides, instead of call signs, it provides an index into a table of calls. And so for our searchable files, which are going to be in CSV format, like in big data style, we have to fill those in, as well as do historical data, get historical data on the locations of all those stations going back to 2009. Now, I got a copy of the Buckmaster ham call database, and I do have software which can read that and then split out when each call occurred, and for the most recent point of an archival log file. So hopefully we can get pretty close to, I mean, people do move from time to time, so you can't just grab what's on QRZ and assume it was good 10, 15 years ago. You got to use a log file from that era. So we have a technique for doing that, which we'll implement. I have a very, as I said earlier, I have a very crude version of that running. We're going to clean that up and as part of our R&D on this new project. So that's the news from Northport. Back to Nick.
Well, fine business. And just for everybody's information, Dave Witten is not here tonight. He's traveling with his wife. So he'll be back online talking later in the week. Next on the list, we have David in one HAC. Go ahead, David.
Oh, good evening to the net. A busy week for me, but the one thing that I wanted to talk about here, we can talk later, but Scotty actually got ahead of me on it, as I wanted to look into the RF to MAX10 evaluation board adapter and offer to help design one if need be, but maybe that's already in process. But I think that would be a great thing to get going, and as well the clock module carrier. I'd like to be able to try out the clock modules as well, since I'm a time nut. Yeah, I think we're beginning to get close to having some real hardware to play with. The one question I wanted to put out there is there documentation on the data engine? I've not been able to find it on the website. I was trying to find that. I found the stuff on the receiver module, but nothing on the data engine except some very rudimentary stuff. So I'm wondering where all the actual design documents might be kept. Back to Nick.
Well, up to this point, nobody's sent in any links on documentation of data formats that I know of. So if anything, usually the first place things go is in the documents directory. And so far we've been working on the board protocols and information.
Right.
So that as far as the website goes. So next on the list, we have Dave, KE8QEP. Go ahead, Dave.
Well, hello, everyone. I guess, unlike you two who still hadn't found what they were looking for, I don't know what I'm looking for, which makes it easier because, and if I find something, maybe it's useful. I don't know. But I've spent some time looking at distance metrics to compare time series, to sort of compare our magnetometer readings from those of NOAA. And in the process, I found out that distance metrics are much more complicated than I could even have imagined, for reasons which I hadn't even imagined. And some of this has been done with magnetometer readings before. So I'm going to try to post some of my results. They may not be useful later in the week, but it's a way to sort of check data for, does it match with the reality? And I did some of that. I don't know if I mentioned last week, with just summarizing the daily logs, taking them seconds, summarizing them by days, and looking at range and other things. And there may be some useful things there. But that's it. Back to Ned.
Well, fine business, Dave, and thanks for your work on that. I've been worried about this because we have a large number of relatively inexpensive pieces of equipment run by inexperienced operators, and most of the data that's been in the scientific archives up to this point have been run by universities, which at least have a research assistant whose job it is to look at it. And we really need some sort of an automated way of saying, well, this data looks suspicious, and maybe somebody should look at it. So anyway, I've been encouraging that. Okay, next on the list, we have James, KG4 DSG. Go ahead, James.
Evening, Dave, and the group. I posted a couple links earlier. One is a follow-up to last week. Apparently, Raspberry Pi 4 gig units are back ordered into 2022, if I can believe that date. And there's another date on there that leads me to believe that may be true. And there's another link to a podcast I heard a little while back, but Scotty was talking about ARDC. There's a long form podcast where they were interviewing the grantors from ARDC and what they're looking for. I'd suggest taking a listen to that if you have any interest at all in writing grant proposals. Other than that, I see that the dev kits at DigiKey are down to quantity 3. I guess maybe we bought them all. With that, back to the net.
Well, fine business. And next on the list, we have, let's see, Jim, K4 BSE. Are you ready? Go ahead.
Good evening, all. Well, I'm still trying to get a little bit of the sand out of my brain from a week at the beach, but having some success at that. And I got to looking at some of my grape data from the last week or so. I'm seeing some funny things in there, but they're only occurring at night when I can't be there. And 1 or 2 of them occurred about this time, but it seems to be running fine now. But for some reason, I get the signal level going up high, and the Doppler shift line zeroes out on 0 hertz Doppler shift, and it just stays there for several hours. So I'm hoping to catch it in the morning and see what's going on. But as far as what this group is talking about, I'm afraid I have really nothing to contribute. So back to net.
Well, fine business. And next on the list is Joe, W7LUX. Go ahead, Joe.
Okay, I got to remember how to run this program. Good evening, everybody. I've been monitoring the grape with a grape receiver and answered a couple of questions on the grape email reflector. And we finally got measurable rain here in northern Arizona. Problem is we seem to get way too much at one time. But anyway, we're dealing with mudslides from a fire burn area of a couple of years ago and stuff like that. That's pretty much it from here. Back to you, Dave.
Fine business. And next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody.
Yep.
I had a bit of a busy week, or well, at least a busy weekend. I was doing some more testing on my VLF receiver, and I was testing its microphonics. I was hitting it with different objects made of wood, metal. It's amazing how microphonic the antenna is. And I was hitting it with a hollow aluminum pipe, and when the pipe would ring, that would transfer to the antenna, and I could hear the tone through the headphones. So I was splashing water on it, things like that, just to see how it would react. And then this past Friday, I plugged it in to test it more, and then I heard this awful squealing sound come through the headphones. At first, I thought it was a grounding problem, but it usually doesn't oscillate if it's not grounded well. So I pulled my foam core, and I noticed that I heard a squealing sound coming from the DC to DC converter. So it was transferring that into the audio path. But that opened up a bunch of problems, because I had a DC. I had the same DC to DC converter fail on me also. What would happen is the voltage input would pull down the voltage source, whatever it's being fed with. And the last time it didn't squeal, but this time it did. So that I tried to think about and investigate what would cause that. And the only thing that I could think of is a voltage spike. Now the data sheet calls for it's spec that it could withstand a spike of 50 volts for 100 milliseconds. But I think that that either it's just at the spec or might be more. It's kind of impractical to put a scope on it when it's outside, so it's hard to tell. So I looked up mitigation measures, and it looked like that TVS diodes would be the best option for my application. So I'd like to talk more about that during the a main session, because I wanted everyone's input on TVS diodes and circuit protection, and I also had a question about the magnetometer power and the long feed lines. That perhaps there could be an issue, as there would be on my VLF receiver with very long feed lines, even though you might parallel the pairs. Other than that, I had an enjoyable dinner with Nathaniel and Scotty on Thursday night. It was good to see him in person. Other than that, I don't have anything else. Back to the net.
Fine business, Jonathan. And next on our list, we have Jules, K2KGJ. Go ahead, Jules.
Okay. Good evening to the net. Not a lot this week on ham-side projects. A number of family issues I had to deal with, and some family projects, including building a Morse code trainer with one of my granddaughters who is interested in learning code and getting her license. Did a little bit of work with getting some of my data from one of the magnetometers up to Dave's repository to see if that would work on a daily basis. And we're getting there slowly. Other than that, not much to report. Back to net. Oh yeah, we did have a little bit of 2 days of haze from the western wildfires. I'm sure some of the rest of you also experienced that. But it was interesting because at ground level, for a couple of days running, visibility wasn't any more than about 1.5 miles. Back to net.
Well, fine business. We had that as well, and we've had wonderful orange moons the last couple weeks. So a byproduct of the fires. Next on the list is Mike, AA8K. Go ahead, Mike.
Oh, thank you. Greetings to everyone listening. Back to you, Dave.
Okay, and I'm going to jump back and catch Kung because I seem to have missed him. So go ahead, Kung.
Hello, everyone. So last week we had the radio blasted physics camp at the University of Scranton. So yeah, I had a really great experience. I helped a little bit with building the crystal radio. We didn't have the time to get to it with the students, but I watched Scotty make the radio, so I made my first crystal radio. It felt a little strange making an electrical device without a power source, but I enjoyed it a lot. And then with the students, we did some physics experiments, and the students got to make their own speaker, electric generator, DC motor, and so on. And the student also got the chance to play around with the SDR website, which was really interesting. And on the last day, we listened to a presentation from Scotty And I have to say that was the first time ever that I understood everything from him. I didn't have any question. Yeah, he also showed us the wolf hound. I never heard of it before. The wolf hound from, yeah.
Yeah.
Yeah, he also showed us the difference between the radio nowadays and back then, how we're going from analog to digital. And he also showed us a funny picture of the difference between a physicist radio and an engineer's radio. He showed us a picture of a handheld device with just a dial and a few buttons, and that would be a physicist radio. And he showed a picture of the room full of electrical devices, cables, and a little console in the middle, and that would be an engineer's radio. Yeah, and regarding the TangerineSDR, after the camp, I had 2 meetings with Scotty. He showed me the wizard encoders for the FIR and CAC filter. Yeah, he showed me how Quartus does the filters, and he also showed me how he manually write the code for the filters, which was really helpful. And he also showed me a little bit about how he's gonna fix the new chip for the Mark II version of the TangerineSDR, and how it's gonna implement the 10 gigi into the new board. Yeah, so it was really, very helpful week for me.
Well,
That's
very
it.
good.
Back to you, Dave.
Yep. And next on the list, we have Tom in 5EG. Go ahead, Tom.
Well, good evening, Dave, everybody. Spent this week getting Quartus 2 installed and running on Ubuntu 20.04. NIOS 2 was a bit of a dog to get working. I ended up having to install the binary of Eclipse, which brings in its own Java runtime binary, which doesn't run. And so then I found another version of Java that did run, and renaming files and making symbolic links. Got all that together and a few edits of the Java config files. I finally got the whole package up and running and all the menus going. So that was nice. This afternoon, this showed up from DigiKey. So I now have one. And I've been on YouTube watching videos and trying to find my first FPGA or the equivalent. All I have to say is the Altera / Intel website's a real mess.
Yeah.
Almost every link is a dead link.
Yes.
So anyway, Google is your friend, and so I've been trying to find documents on how to go through the 12,000 menu options to build an FPGA. So that's it for the week.
Tom, are you taking notes on what you're doing? Usually do. So
yes, I have notes on how to build a working NIOS 2 environment on Ubuntu. It's been successful on Ubuntu 18 and Ubuntu 20 virtual machines. Okay. And on the Ubuntu 20 real machine, I plugged in the board I got, JTAG comes up and runs, and the NIOS menus come up and build. So yes. I think I've got most of this up and running.
I need to do that to experiment with the UART.
Okay.
Part.
I'll try to take the 20 or so documents I created and putting them into one completely incomprehensible treatise.
Well, I have an idea how the parts work, but I haven't built one before, so at least I have somebody to ask a question. So
yeah, there's a lot of messy pieces trying to get it all to work.
I'm well aware of that.
But anyway, it seems to be up and running now, so that's
okay.
That's good. I'll collect what I've got. Should I put together a quick document to put up on the development?
Okay.
Okay.
That'd be good. Then everybody can look at it.
Probably want to call it NEOS.
NEOS, okay.
Yeah, see, it's whether you're a Finn or an American.
Yeah.
The Finns would say NIOS.
Like a fear filter?
Like a fear filter. Well, I had 10 years or 12 years of working with Phil.
So does Phil call it NIOS or NEOS? Oh, he doesn't use embedded software
He
processing.
doesn't do that. Well, he did do some of that, but he pretty much wrote from scratch with Kurt's help.
Yeah.
And by the way, those Kurt videos are still up on the OpenH PSDR. So they're FPGA or Verilog programming videos,
Okay.
and they're still on the OpenH PSDR.
And I don't know if, I think, I wonder if my articles from QEX are up on the ARRL website, because the older stuff is up now. I don't know, they never did put QEX stuff up, and it's be from 2015, I want to say.
I'll
But
spend a
I
little
think-
time finding.
Scotty, I believe I have a copy of your QEX article on the HamSci website that I got permission from the ARRL to post there.
Okay, well, there's like 4 articles that I wrote on getting started in FPGAs back in the early.
Oh, okay. Yeah, I don't have those.
So I'll
Yeah.
tell you, Scotty, it was really good to get started, but it kind of tapered off at the end.
It did taper off at the end because it got complicated and it got hard to write. So, so it's like the proof is left to the student, right?
Yes, that's one of those kind of deals.
The interested student.
The
Yes.
interested student. That's
Yes,
right.
the interest, and it's trivial.
And the trivia, that's right.
Yes. It's,
That's why we don't show it, because it's trivial.
right.
Yes.
Yeah, trivial exercise left to the interested student.
So I guess we're through the list. I don't see anybody that I didn't call on, so we're open for general discussion. Scotty, I do have a question for you. I looked for Arria development boards, and the cheapest one I could find was $4,000.
Yeah. So give
Did you
better
buy
buy
two?
quick. Get buy. Yeah. Did you get 2?
No.
Yeah.
So-
they are expensive, and let's just hope we don't need one.
Yeah,
Like we need
maybe
the
that
other
our
ones.
development boards will just we can write the code and then try it on the other ones, on the other chips.
Well, we're going to write the code anyway for MAX10
Right.
because we're going to be writing it for the development boards. So then we'll be porting that code over to the Arria 10.
Right.
And so which part did it have on it? Do you remember? Was it on the
I-
Jurassic website or was it on a different site?
It was on Intel's site where I was just searching for Arria boards and development boards.
Okay, I'm just going on the Jurassic.
And I
site.
found some that were as high as $6,000 a piece.
Yeah, there's let's see. Here's one with an Arria 10 GX 1150, which is too small for us. It doesn't have enough IO, and it's 3250. That as in 3,250,
Yeah.
not as in $32. It's-
Yes.
And then let's see, 6,000, 6,000. Here's one for 3,000, which uses that's an SoC one with the dual core ARM. We don't use that. Yeah, that's a 150.
Can someone spell, what is this, Arria?
Okay, here, let me share my screen. So Arria 10 is what we're going to be using here for Mark II. And you can see the prices are very much reasonable for millionaires. The part
I
we're gonna
noticed
be-
some of them are on PCIe boards.
Yes, because the Arria 10 has a PCI Express 8-lane Gen 3 built into the chip, a hard PCIe, which we're not going to use, unfortunately. But trying to see any ones that say SoC, like down here, that system on a chip, that means it includes an ARM processor, either a single. I think they're all dual cores on the Arria. But these are all, oddly enough, these are much smaller because we're going to be using a 10AX270. This number here, like this 115, that's 115,000 LEs. This one here for 4,500, it doesn't say which part it uses. Wonder what.
Okay, so have you picked a part, or are you still
Yes.
sorting through?
Wait a second. I'll give you, if you're interested, I'll give you the part number. It's It's a 270,000 LE part with 12 17 gigahertz transceivers on it.
Okay, can you give me a number?
Yeah, as soon as I find it here, and I'm on the mess on my desk. It's gonna be a 10AX 270, I believe, is the beginning. Hold on a second. Sure, I've got the number handy, no problem.
Well, we can continue and you can put it in the chat.
I'll put it in the chat when I find it here.
Okay.
But I'm looking at this one here, and it doesn't say anything about what the, oh, this is SOC. But you can see up here, this is the Sfp connectors right here. These are the 10 gig E. It's got two of them. We're only going to have one. And then it's got a PCI Express connector here, as well as these look like UFMs, I think, not HSMCs. Oh, here we go, specs. Let's see what it might say for, yeah, 10.8S. See, that S means SOC. So it's not what we're going to be using. Ours does not have a system on a chip. It's just logic. 115, 115, 115, 115. Seems to be the popular part, the 10AX 115. So let me do this. At the risk of going to the Intel website, this is the one we're going to use right here, Arria 10 GX. And if you go to this, so you have to know where to go here to get the iChart table. Okay. So this is the part that we're going to use right here, the third one up from the bottom. And it's going to be a GX part because the SX has the SoC processor in it. We're not going to use that. So it's going to be the GX 270, 270K LEs. And you can see down here, it has, it says PCIe hardened IP Gen 3 by 8. It has two of them actually, which we're not going to use again. It has 24 17 gig transceivers. It's too bad it doesn't have any 25 gig transceivers because we could do 100 gig Ethernet that way.
Okay, Scotty, when you say there's no SoC, does that mean there's no software processor core?
No, there's no
something else.
There's no hardware processor core.
Okay.
The SoC has a hardcore processor, which is probably an unfortunate term, but they call it an HPS, high performance processor system. If you look, it does call it a hard processor system. So that's in silicon. But it says dual core here. Well, that's for the SX parts, not for the GX parts. So the SS parts, the GX parts, my guess is the same exact die, and they just have either a non-functional processor or they zap it to turn it off.
Okay, so we will have a soft processor option then.
We will have a soft processor option. You have that in every FPGA, as long as you have enough room to put it in, then we're going to have lots of room.
Okay, very good.
And you come down here and you see the package we're going to use is the 29 millimeter F780. So it's a fine pitch 780 ball FPGA, 29 millimeters square. And with the 270, we get 360 IOs. And we get 48 LVDS pairs. I think that's, oh no, that's not right. Oh, that's high voltage count. So that's 3.3 volt IO there. This is LVDS pairs. If you look down here, is the key. That looks like an IP address, except for the commas. So anyway, and then the transceiver count is last, which is
12.
24.
Not the one you have highlighted.
This
12.
one here. This one here is the one we're going to use. So you get 12 transceivers. We need 8. You get 156 LVDS pairs we need 17. I forget the exact number, but it's 3 times 48, I believe, is the number that we need. At any rate, we'll make do with the one with this number. Because if we go to the next bigger part, we can get a few more IOs. The problem is that this part is, look how much bigger this is, 35 millimeters on the side. The part that we're using right now is this one. The package we're using is a 27 by 27. So this is only 2 millimeters wider in both X and Y than the one we're using. This one is 8 millimeters wider in both directions. That's a lot, 8 millimeters in what we've got packed in. That's a lot of space. If we went to this package, we probably would have to make the board bigger to fit all the routing in. So that's why I'm kind of trying to be conservative. And what's going to happen is, because of the reduction in IO, we're going to have to take off the USB 3 and USB 2 and the SD card, most likely. But those were all just afterthoughts anyway, not really required. The 10 gig E is really the most important thing that we want to get out of this module, this board. 10 or 40 gig E. So anyway, this is the part right here, the GX270. And like I said, I'll find the full part number, because it's interesting, because the part number not only now has speed grades on the internals of the process of the logic, but it has transceiver speed grades. So it's got two numbers in the part number indicate speed grade. I think now they used to have a key here. They had the part number all expanded out, and they'd show you what each field was. But I guess they don't want you to know that anymore. So, and you're right, the Intel website is difficult to find stuff on. It took me a while to figure out that I could still get this table, because this is the really useful table to try and pick, well, which size you're going to use and how many IOs does each one have. And normally I would be happy to use, see, with this F780 package, 360 IO is the most I can get, even if I pick the biggest part in that package, which is the 480. So I would have to go to the 1152 package to get more IOs. And then I would have to go, to get significantly more, I'd have to go up here to the 480. This part's going to be way too expensive for us. So this is almost 300,000 logic elements. That's pretty good. That's bigger than or almost as big as the biggest Cyclone 5. And this is a 10 nanometer geometry. I believe it's 10 nanometer, which means that it's much faster than the MAX10. So we have a lot less trouble with things like DDR at 250 megahertz coming from the ADCs, which is really marginal on the MAX10. On the Cyclone 5, it's doable, but it's easily doable on this. And the other thing that we get that's a little bit nice is, look at this. Hardened single precision floating point multipliers. Look at this. 1600 18 by 19 multipliers. These are hardware multipliers. And they've got floating point multipliers and adders. I mean, this is something that the Max doesn't even have. Okay. They don't have floating point units. And it has, I think, 180 multipliers. So you get almost 10 times the number of multipliers. Well, this is going to make building lots and lots of virtual receivers easy. So if we do this, there's going to be no problem, I think, getting 16 virtual receivers out of the thing easily because of the size. And we'll have, and even if you want to put a 1 gig E SFP module in and run it at 1 gig and run copper, you're still going to have the resources in the part to do all those receivers. So the first thing you run out of is bandwidth on the Ethernet cable.
Yeah. So Scotty, the transceivers that run at 17 gigabits per second. What's the intention for those?
To run the 10 gig E module.
Okay. So typically the interface on the 10 gig E's isn't that like 4 lanes wide by 2.5 gig?
No, it's typically an SFP plus is 1 lane at 10 gig.
Okay, very good.
And you can do, okay, so the 3 interfaces that are of interest, anyway, that I found interesting were the SFP plus, which is 1 lane at 10 gig either direction. So that's 2 transceivers, right? The second one would be a QSFP plus, which stands for quad SFP plus, and is 4 lanes at 10 gigs. So that's 40 gig Ethernet. And then there's the QSFP 28, which actually runs the lines at 28 gigahertz. And they typically, they're spec to 28, but they typically run at 25 gig, which gives you 100 gig on 4 lines. And if you want to use like ZenPack or some of the other ones, you can do the 4 wide 2.5 gig lines. But if we have lines that run at 17, we just use those. So for instance, if I wanted to use a Cyclone 5 that only had 3.1 gigahertz lines, then I would have to use a ZenPack or one of those that use 4 of them to get to 10 gig. But since we have ones that run over 10 gig, we can use it. We can do that.
Scotty, I got a question.
Fire away.
I'm just browsing around DigiKey here, and I'm wondering if I found the part. It's a 780 FPGA, 360 IOs, 270,000 logic elements. Is that what we're talking about?
That's not right. What was it? What did the part number begin with?
Well, I'm just reading the specs. The part number is I'll put it in the chat. It's a 10AX027E.
That's the one.
4F29E.
10AX027.
I'll put it in the chat here.
Yeah, okay. So it's going to be number of IOs 360, and it's going to be the 780 29 by 29.
Question I got really is the price. It's showing 600 plus quantity 1.
Let's just say that's not the price.
Okay, that's what I was wondering.
Yeah, and that was the thing, is when I looked at these prices myself, I go, holy cow, we're out of luck, because there's no way we're going to afford it. And that's the cheapest one.
Yes, it is.
And then it goes up from there up to over $1,500 if you continue on down. I think it goes, I saw one here, it's $1,500. Depends on the speed grade. This E here is the transceiver speed, and the 1 here is the logic speed, 1 being the fastest. So I think you go up here and you see that you got an E, and then you got a 3 here. So this is a slower part. Anyway, so no, we'll be able to do this at much lower prices than that.
Okay, that's what I hoped, and that's what I wanted to hear.
Yeah. So yeah. No, in fact, I'm hoping I can sell the board cheaper than that. So, and I know some of the boards that I've seen, like for instance, that MAX10 board that we all just bought for $199. If you go to buy that FPGA at DigiKey, you're paying $200 for it. Well, but I get the whole board for $200. So it's being subsidized somehow by Intel. They must give Thoracic a better price on it. And I'm not convinced. I don't know if Intel makes that board or if Thoracic makes it. Intel makes it and lets Thoracic sell it, or if Thoracic makes it and sells it and puts the Intel brand on it, I'm not sure.
Well, just as a comment, even at that price, that $700 price, compared to what else is out on the market, that's still a bargain.
It is, and that was one of the reasons why I think we want to use these parts, because I went to a Xilinx seminar, and I used one of their I don't even remember what it was. It was a U03, I think, was in the part number. Anyway, it was a small the lower member of a higher order system, that makes sense. So it was their higher order parts, but it was one of the smaller ones, like either the smallest or second to smallest. And even that part was like over $300. And compared to what we pay for what we get here, I think this is much better. So aside from being, more of an Altera fan, because I started out in Xilinx and then I kind of did a mix of both. And then lately it's been mostly Altera Intel stuff because just because it's whatever our customers came to us to ask for. Because if they come in with the Xilinx design, we really are we can't switch them to Altera and vice versa, because we're supposed to be agnostic. We'll help them with their FPGA design, whatever one they pick. If they come in and they don't know what they want, then we can kind of steer them in either direction we want. But if they come in with an Intel design, we can't suggest that they do Xilinx or vice versa. Otherwise, we would stop getting referrals from Xilinx or Intel.
Yeah, the only other comment I got is obviously none of those are in stock.
Yes, and you did notice that.
Yes, I did.
Zero, everything is zero. And so, I'm asking, well, when can I get these 027s? And he's telling me October, but he's also telling me, and he's very cryptic, because the way they get the 10 pieces or 20 pieces that we need is they borrow them off of someone else's order. Somebody who has an order for like 1,000. They borrow them off of the order in October, and then they replace them in April, because they're not really going to use 1,000 all at once. They're buying them to put in their program and be used up over a period of months. So if it's only a few, they can kind of borrow a few and then replace them, and Intel can juggle the amounts. But they got to have orders for the parts. They have to have parts being sold. And what the Altera guy, so the Intel guy says, the rep says, nobody uses the part that you use, the MAX10 part, because we're using the fastest and the highest temp part. So he says, I don't have any orders to pilfer from. There's nobody to borrow from because nobody's using it. So, but in this case, in the Arria 10, there are people to borrow from. So he won't tell me, but he's hinting that it might be earlier than October. Don't know.
Well, Scotty, don't forget, we're just about into August.
I know October is only 3 months away, right?
Yeah.
Well, actually, the beginning of October is only 2 months away.
Yes.
Yeah, so that's, like I said, we'll be hard pressed to get the design ready to build by October, especially if we can make this. We get this grant, we can make this adapter board work. We're going to have lots of stuff going on between now and then.
Right.
So that's the story.
So on a slightly different topic, I heard Dave McGaw asking about data formats, but I didn't quite understand what the question was. Dave, you still there?
I wasn't asking about data formats. I was asking about the data engine.
Oh, okay.
Yeah, and I should be putting that stuff up here pretty soon because it's pretty much done and it needs to be reviewed. So
yeah, what do you use for design for schematic and layout?
I use OrCAD for schematic, and we use pads for layout.
Oh, good. I'm a pads guy.
Okay, good.
And I do know my way around OrCAD if I have to.
Okay, I'm using an extremely old version of OrCAD.
Yeah,
I have a much
me
newer
too.
version, which they screwed around with all the menus, and I don't like it, so I back to the old one.
No,
But
we have some of our boards that are in an old form of OrCAD, so that's what I have.
I'm in 9.2.
Yeah, it's somewhere around that.
Yeah, and they're using and they've changed the format of the schematic capture of the database like twice since then.
Yeah, I usually do schematic capture in pads logic, but I know my way around OrCAD.
Scotty, can you stop sharing?
Oh yeah, sure.
And yeah, I'm a
okay
pads guy from way back.
Oh, okay. So do you have a copy of pads?
Yes, yes, I do. fairly new, fairly
Okay,
recent.
good. So when I
So
can
if you
send you
need
the
some
path.
help, I can.
Well, I can send you the
Gotcha.
past database and you can look at it and see if you see
Oh.
anything untoward.
No, that would be great.
I'm gonna need to take off early tonight. See you all next week.
7-3, Tom.
See you.
Thanks, Tom.
Good night, Tom.
Just a quick comment on Pi 4 availability. I ordered a 4 gig Pi 4 about 4 days ago and it just came in today.
What did you order?
A 4 gig Pi 4. And I just received it today.
Was it a regular Pi 4 or a compute module?
This is a regular Pi 4 4 gig.
Okay.
So where did you find it? What outlet had them?
I found it on Amazon.
Oh, really? Okay.
There were 2 or 3, 2 of them were out of stock and 1 had stock.
So do you think this is going to be a problem now? Is it going to go out of stock and be on back order too?
Good question. I don't know.
They build a lot more of these than Intel makes FPGAs, I would bet.
Yes.
Probably by orders of magnitude.
I think it's isn't it the most common computer in the world?
Yeah. Let's see, they started
Simply
out
because of the
thinking-
price.
Well, they were going to build 350,000, right, at first.
Yeah.
And I think, I don't know how many months it took them to get to 1 million, but it was not very long.
Well,
They're
I think-
over 40 million now.
40
So-
million?
Over 40 million.
So Scotty, if you asked your question at Dayton about how many people own Raspberry Pis, yeah, I think and how many each own, you'd get a very different answer.
Well, I was the most ownership I got was over 25.
Yeah, I think you're gonna have people with over 100.
Well, I told them too, you got to subtract the ones that are still in the box, and he didn't even blink. It was like, no, they're all out running, doing something. I guess he has one in his can opener or one in his refrigerator, and one in his corkscrew for his wine bottle. It's like,
Well, Scotty, I'm gonna have to go as well.
Yeah, I think I'm gonna head out too. I'm still
Yeah, same
recovering.
here.
I just wanted to say quickly, whoever of you guys out west let the smoke out, stop it.
Hey, we've had rain here for the past 3 days.
Yeah, well, we're getting thunderstorms. We're in the middle of one right now. But today was incredibly thick smoke.
Yeah.
When I came back
Choking.
from Scranton, they said when I took off from O'Hare, they said it was warmer in Chicago than it was in Phoenix.
Yeah, I can believe it. Yeah, we've been getting that up here too sometimes. But we're at least cool most of it, but we've gotten a lot of rain and now we're getting a lot of smoke.
So where's the smoke coming from? You're in New Hampshire, right?
Oh, yes, but this is the California and Oregon fires
yeah,
and
and
some from Canada.
Yeah, Western Canada. If you look at the jet stream, you see what's bringing it over this way.
Yep. No,
Wow.
well, as it said, we are the nation's tailpipe. Everything comes over us. That's why Mount Washington said to have the world's worst weather, because the jet stream comes over here and dips down.
Well, I heard during the Dust Bowl, they were getting dust or dirt deposited on ships off the Atlantic coast.
Oh, yeah.
Mhm.
Well, we got ash from Mount St. Helens.
Yeah.
We don't allow any of that in our state. We send it north to you guys. That's
Right.
a joke around here because the joke is that we don't allow thunderstorms in Phoenix because because they come in from the Gulf. So they come in from the southeast and they come up, and what happens is they hit the thermal dome of Phoenix and they split and they go around the city. So
Right.
really, since I've been here, it's gotten markedly less. There's just as many off in the distance as you can see, but a lot of them don't even get here because they split and go around. So
Yeah, I've got a similar geography here, not because there's a city, but because there's a mountain in the way. When things generally come from the west, they split north or south of me, which is a good thing for a ham. So right now they're coming from the north, so that we don't get quite so shielded. So we're getting lightning nearby.
Well, especially when it's an ice storm, you want it to go around you.
Yes.
Well, good night, all. Go
All
on
right.
GMT.
Okay.
73. We'll catch you next week.
73, everyone.
73.
73.
Good night.
Good night, everybody.